Why do electronics fail from thermal runaway? Imagine a tiny electronic part suddenly overheating and causing a chain reaction that leads to a device melting or catching fire. That's what thermal runaway is all about. It happens when heat inside a component starts to increase faster than it can escape. This creates a cycle where more heat makes the component's electrical properties change, which then causes even more heat to be generated. The process spirals out of control until the component is physically damaged or destroyed. This often begins in parts like semiconductors or lithium-ion batteries. When these parts heat up too quickly and cannot dissipate the heat, their electrical resistance changes. Sometimes resistance drops, allowing more current to flow, which produces even more heat. Other times resistance increases, but the current still rises due to other factors, still generating excess heat. Either way, the heat builds up rapidly. In electronic devices like transistors or diodes, poor cooling or blocked airflow can trigger this process. If dust collects inside a device or a cooling fan stops working, heat can't escape efficiently. High ambient temperatures or cramped spaces make it worse. For example, inside aircraft wiring systems where ventilation is limited, thermal runaway can occur more easily. Lithium-ion batteries are especially vulnerable. When they overcharge, get damaged, or are exposed to high temperatures, a series of chemical reactions happen inside. The electrolyte decomposes, releasing heat and flammable gases. The separator can melt, causing internal short circuits. The cathode material breaks down and releases oxygen. All these reactions releases more heat, speeding up the process and often leading to fires or explosions. This failure is dramatic because once it starts, stopping it is very hard without intervention. The heat overwhelms the component's cooling ability, causing it to physically fail. To prevent this, engineers focus on good heat management, proper cooling systems, and avoiding electrical abuse like overcharging or short circuits. Regular maintenance and keeping devices clean and well ventilated are key. Understanding how heat and electrical properties interact helps us design safer electronics and avoid these destructive failures.